Hello everyone, welcome to the tutorial session of course Principles of Signals and Systems. So today we will discuss about the week 11th, like whatever topic is taught in the week 11th lecture, we will discuss some of the question based on that, and we will try to understand the concept through questions. So we will take various examples which is discussed in the week 11th of this course. So the first example is, find the IDFT of IDTFT, that is inverse discrete time Fourier transform of 2 pi del omega minus omega naught. So we know that the inverse Fourier transform of this can be written as IDFT of 2 pi del of omega minus omega naught is equal to 1 by 2 pi integration over minus pi to pi 2 pi del of omega minus omega naught. We have to use the different notation which is for discrete time, and e to the power of j omega n d of omega. So in this way we can write the inverse discrete time Fourier transform of 2 pi del omega minus omega naught. So after that this 2 pi and 2 pi will get cancelled, so our integration will become minus pi to pi del of omega minus omega naught e to the power of j omega n d of omega. Now we know that when omega is equal to omega naught, then only this integration will become 1, and at omega is equal to omega naught, e to the power of j omega naught n will be constant, it will come out, and the integration of minus pi to pi, this term will become 1, so we can directly write into 1. So the answer will be e to the power of j omega naught n. So here we can write e to the power of j omega naught n is the DTFT pair of 2 pi del of omega minus omega naught. Okay, so DTFT of e to the power of j omega naught n is 2 pi del omega minus omega naught, and then what will be the inverse discrete time Fourier transform of this? This will be equal to e to the power of j omega naught into n. Okay, so this was just a simple question. So now we will take one more example that is based on the cosine signal. If you have any doubt, then you can ask in the comment box of YouTube. All this video will be uploaded on YouTube, and you can ask there. We will reply in the comment. So find the DTFT of cos of omega naught into n. So we have to find the DTFT of this term. So we can write cos of omega naught into n, that is equal to half of e to the power of j omega naught n plus half of e to the power of minus j omega naught n. So we can write cos omega naught n like this. So now we know the DTFT of e to the power of j omega naught is 2 pi del omega minus omega naught. So this will be 1 by 2 into 2 pi del of omega minus omega naught plus 1 by 2 into 2 pi del of omega plus omega naught. So this will be equal to pi del of omega minus omega naught plus pi del of omega plus omega naught. So finally the DTFT of cos omega naught n, that is equal to pi del of omega minus omega naught plus del of omega plus omega naught. Okay, So this is the DTFT of cos omega naught n. So now we can take one more example. That is, find the IDTFT of 1 by 1 minus a e to the power of minus j omega squared. Here it is given that mod of a is less than 1. So first of all we will assume let x of n is equal to a to the power of n u of n. Okay, so now after this assumption, if you find the discrete time Fourier transform, then that will be x of omega, that will be 1 by 1 minus a e to the power of minus j omega. Okay, so x n and x omega forms the discrete time Fourier transform pair. So this will become like this. Now when you do derivative of x omega with respect to del omega, then it will become like 1 into this, so minus of it will become minus of first of all in denominator it will be 1 minus a e to the power of minus j omega squared. Okay, in numerator it will be 1 into, it will become minus j, that is minus a here, e to the power of minus j omega into minus j. Just you do derivative of fraction, you use that formula, you will get this value. So after that it will become minus of j a e to the power of minus j omega divided by 1 minus a e to the power of minus j omega whole square. So this is del of x omega with respect to omega. So now you multiplied both sides with j, then we will get j del of x omega with respect to omega, means differentiation of x omega with respect to omega, and here it will become minus j into j, that will be minus of minus 1, that will be plus 1. So it will be a e to the power of minus j omega divided by 1 minus a e to the power of minus j omega whole square. Okay, so after all this what we get, we can write first we will write in the simple way. So this is equal to a e to the power of minus j omega divided by 1 minus a e to the power of minus j omega whole square. So if so, you know that it forms the Fourier transform with a pair of n x n. So this will form with n into here xn, what we have assumed a to the power of n into un. So that is the Fourier transform of n into a to the power of n into un. So the Fourier transform of, we know that derivative rule in the DTFT. So using that, n a to the power of n un, the Fourier discrete time Fourier transform of this term will be a e to the power of minus j omega divided by 1 minus a e to the power of minus j omega whole of square. So now when you multiply with minus on the both the term, like we are trying to derive something else. So first we'll do multiply with minus on both the sides. So we will get minus of a e to the power of minus j omega divided by 1 minus a e to the power of minus j omega whole of square. So we can write this as, here we can add 1 and subtract minus 1 also. So after that this will become, this by this will be 1 by 1 minus a e to the power of minus j omega minus 1 by 1 minus a e to the power of minus j omega whole square. Okay, this we know that this forms the Fourier transform pair with a to the power of n un, and let's suppose this is x of tilde of n. Okay, so minus n a to the power of n un. Now if you do inverse discrete time Fourier transform of the terms in the right hand side, so you will get a to the power of n un minus x tilde of n. Okay, so now taking x tilde of n in left hand side, we will get that is equal to a to the power of n u of n plus n into a to the power of n u of n. So now take common, we will get n plus 1 a to the power of n u of n. Okay, so n plus 1 a to the power of n un have the Fourier transform of this x tilde n have the Fourier transform this one. So this will be 1 by 1 minus a e to the power of minus j omega whole of squared. Okay, so this is the IDFT of IDFT of the right hand side. So in this way we can derive such formula. So we will take another question. Example we will take, find the DTFT of discrete time Fourier transform of unit step signal, that is u of n. So first of all we will write the definition of u of n. So u of n is equal to 1 when n is greater than equal to 0, and this will become 0 for the negative value of n, that is n is less than 0. So let's write u of n as x of n plus y of n. Then our x of n is equal to half for all value of n. This means now y of n will become half for n is greater than equal to 0. Then only this u of n will become half plus half, that is 1 for the positive value of n. And this will become minus half for n is less than 0. So now for negative value of n, u of n is half minus half, that is 0. We all know that the DTFT of 1 is given as 2 pi del of omega. So the DTFT of half will be pi of del omega. Okay, so the DTFT of here x of n, that is x of omega, that will be here pi of del of omega. Now yn is equal to half, so we can write here y of n minus y of n minus 1, that is equal to del of n, because y of n is minus half. So when you do y of n minus 1 for the negative value of n, this will become del of n. So now when you take the Fourier transform of y of omega, means y of n, you will get y of omega minus e to the power of minus j omega y of omega, that is equal to 1, because Fourier transform of del n is 1. So here we can take y of omega common, then 1 minus e to the power of minus j omega will be the leftover term, that will become 1. Then our y of omega, that will be equal to 1 by 1 minus e to the power of minus j into omega. And we know that u of n, that is equal to x of n plus y of n. So u of omega, using the linearity property, that is equal to x of omega plus y of omega. So here we can write u of omega is equal to x of omega is pi into del of omega, and y of omega is 1 by 1 minus e to the power of minus j omega. So this is the DTFT of unit step function. If you have any doubt, you can ask in the comment box. Now we will find the DTFT of accumulator function. Like next is, this is one of the property also, accumulation property of DTFT. So what is accumulator function? That is a summation function. So let's suppose y of n, that is equal to summation of x of k is equal to 0 to n. We know that the DTFT of x of n, that is equal to x of omega. Now we have to find the DTFT of y of n, that is the summation of x of k, and k is equal to 0 to n. So this is just the accumulation property of DTFT. So we can write here like we can simply write like y of n equal to summation of x of k. Here k is equal to 0 to n. So in this case, this we can write simply as x of n convolution with u of n, because this term can be written as summation of x of k into u of n minus k, and here k is equal to minus infinite to infinite. So we can write equivalently as this term. So this is also similarly equal to summation of x of n. Okay. So now if you take the DTFT on the both the sides in that equation, we will get y of omega, that is equal to x of omega into u of omega. We all know that the DTFT of u of omega, that we have already derived before, that is pi del omega plus 1 by 1 minus e to the power of minus j omega. So this will become pi into del omega plus 1 by 1 minus e to the power of minus j of omega. So this will, when you take all the term out, then it will become pi of x omega into del omega plus x of omega divided by 1 minus e to the power of minus j omega. Okay, so now our y of omega, that is equal to pi, and if omega is equal to 0, then that term is valid, so it will become x of 0 del of omega plus x of omega divided by 1 minus e to the power of minus j of omega. So basically that is the DTFT of the accumulator. So we will take some other example also. So this is simply the DTFT of accumulator. So now we will take one more question. So this question is based on the impulse response of the discrete time system. So the question is, that is the classroom question which is taught in the NPTEL lecture series. So the question is, the impulse, the difference equation is given. Five by six y n minus 1 plus 1 by 6 y n minus 2 is equal to x of n, and we have to find impulse response. Okay, so we have to find the impulse response of this given difference equation. So first of all, we will take DTFT on both the sides. So we'll take such kind of difference equation and we'll solve it, so that we will understand how to solve such kind of problem which is based on the difference equation given above. So taking DTFT on both sides, so y of n will become y of omega minus 5 by 6 y of omega, here it is n minus 1, so it will become e to the power of minus j omega plus 1 by 6 y omega e to the power of minus 2j omega, that is equal to x of omega. So first we'll write up to this. Now what we'll do, we'll take y of omega common, then it will become 1 minus 5 by 6 e to the power of minus j omega plus 1 by 6 e to the power of minus 2j omega, that is equal to x of omega. Now we know that h of omega, that is equal to y of omega divided by x of omega. So we'll take this term in the left hand side to the right hand side, and that will become 1 by 1 minus 5 by 6 e to the power of minus j omega plus 1 by 6 e to the power of minus 2j omega. So once this is done, then we get h of omega, that is equal to y of omega by x of omega. This term will be equal to 1 by 1 minus, we have found above, that is minus 5 by 6 e to the power of minus j omega plus 1 by 6 e to the power of minus 2j omega. So this we can break, we can factorize in this way, like 1 minus 1 by 3 e to the power of minus j omega, because minus 1 by 3 into minus 1 by 2 is 1 by 6, and 1 by 3 plus 1 by 2 is equal to 5 by 6. So we'll break into this term like this. When you multiply, you will get this, the terms in the denominator in the above equation. So after that, what we can do, we can write so now what we have to do, we have to like this not like we have to take this and just separate into the fractional part. So either you can take a by 1 minus half of e to the power of minus j omega plus b by 1 minus 1 by 3 e to the power of minus j omega. So after solving this, when you equate the numerator to a in terms of a and b, you will get a is equal to 3 and b is equal to 2. So here you will get 3 by 1 minus half e to the power of minus j omega plus 2 by 1 minus 1 by 3 e to the power of minus j omega. Then like if we take 6 common here, then it will become half 1 minus half e to the power of minus j omega, and this will become here b will be minus 2, sorry, and this will become minus 1 by 3 1 minus 1 by 3 e to the power of minus j omega. So now you can see this 1 by 2 is same, 1 by 3 is same. So this you can simply write, when you do IDFT, this will become 6 half into half to the power of n un minus 1 by 3 to the power of n un. So this is our h of n, because when you do IDFT of h omega, then we get h of n. So h of n is equal to simply 3 into half to the power of n un minus 2 into 1 by 3 to the power of n un. So this is our h of n. Okay, so in this way we can find impulse response of LTI system described by differential equation. Okay, next question we'll take from the class example only. Let's suppose in the figure it is given, this is our input x of n, and it is summed here. So this is our output y of n, and one delay element is added. This is our delay element. So this will become x of n minus 1, because one delay element is added. So find h of omega, h of n, and 3 dB frequency. So we will see all these terms and how to find this. So first of all, we'll write the difference equation. So yn is equal to, here you can see x minus n, xn minus 1 is going, here it is xn is going. So we can simply write yn is equal to x of n plus x of n minus 1. Okay. Now this is the difference equation for above system. So let's suppose x of n is equal to del of n and hn is equal to then del of n plus del of n minus 1. Okay. Here h of 0, that is equal to del of 0, that is 1, and that is equal to del of 0 plus del of minus 1, that is equal to 1. H of 1 is equal to again del of 1 plus del of 0, that is equal to 1. Here we get h of n is equal to 1 for n is greater than equal to 0 and less than equal to 1, that is n is equal to 0 and 1, and it is 0 otherwise, and that is also n is equal to 0 and 1. Now take DTFT on both sides of equation yn is equal to xn plus x of n minus 1. So here we will get x of omega plus x of omega into e to the power of minus j omega, that is equal to y of omega. Okay, by taking DTFT on both the sides. So after that, when you take x of omega common, we will get 1 plus e to the power of minus j omega, that is equal to y of omega. So now our h of omega, that is equal to y of omega divided by x of omega, this will become 1 plus e to the power of minus j omega. Now what we will do, h of omega, that is equal to, let's suppose if we take common e to the power of minus j omega by 2, then this will become e to the power of j omega by 2 plus e to the power of minus j omega by 2, because when you multiply these two terms it will get 1, and when you multiply these two we will get e to the power of minus j omega. So that's why we are doing this simplicity. And now we know that this term is equal to 2 into cos of omega by 2. So our h of omega, this will become e to the power of minus j omega by 2 into 2 of cos omega by 2. So this is a frequency response. H of omega is also known as frequency response of the given linear time invariant system. Now magnitude of h of omega, that is equal to magnitude of e to the power minus j omega by 2 into 2 of cos omega by 2. So this will become magnitude of this. So this magnitude is 1. So this is equal to 2 of cos of omega by 2. That is magnitude of h omega. So h omega will be maximum when omega is 0, that is equal to value is 2. Now at omega is equal to pi and minus pi, cos omega by 2 will be 0, and this same curve will repeat. Okay, so maximum of h of omega, that is equal to at h of 0, that is equal to 2 into cos of 0, that is equal to 2, and h omega is equal to 1 by root 2 maximum of h omega. This is our 3 dB frequency, omega 3 dB. So this will become 1 by root 2 into 2, that is equal to root 2 into root 2 by root 2, that is equal to root 2. So this omega naught is equal to omega 3 dB. So here now we will substitute the magnitude, that is 2 cos omega naught by 2, that should be equal to root 2. So finally we will get cos of omega naught by 2 is equal to root 2 by 2. This will become 1 by root 2. So omega naught by 2 is equal to pi by 4. So omega naught is equal to pi by 2. So this is the omega 3 dB frequency, that is equal to pi by 2. This is also known as 3 dB frequency. Okay. So this was the question what we have solved now. So we will close this lecture today only, because this lecture was little late because of this G20 demo. G20 visit was there in IIT Hyderabad, and we had some ministers came there, so we have to show some demo from our lab and project. So that's why I took this lecture now. Last lecture will be on Monday. We'll take a longer lecture on the next Monday. Thank you everyone for attending today's class. Bye bye. If you have any doubt, you can ask in the YouTube comment box. Thank you so much.